Now we're going to study two special right triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle. And these triangles you'll find to be very helpful to you, especially later when you study trigonometry. But let's start off with the 30, 60, 90 triangle. And I'm going to begin, before we talk about 30, 60, 90, I'm just going to start off with a equilateral triangle so that all the sides here, we'll just say, are L units long. Okay? So L units long, and all the angles are 60 degrees. So this is a, equilateral, equiangular. All the angles are 60 degrees. They add up to 180. Now what I want to do is I want to drop a perpendicular bisector down here. Okay? And what that perpendicular bisector is going to do is it's going to bisect this length L over here so that this length right here is 1/2 of L, and this length over here is also 1/2 of L. Okay? And this angle up here is 30 degrees. It's been bisected, and this angle is 30 degrees. It started off 60, but I bisected it, so now it's 30. Okay? And of course, we have the altitude here. Okay. Now, let's think about, let's just work through this and use Pythagorean Theorem here. We know that a squared plus L over 2 squared, in other words, I'm just using the Pythagorean Theorem, and I know that this side squared plus this side squared equals this side squared. So I've got a squared plus L over 2 squared, and that equals L squared. Yeah, so let's see what we've got here. We've got a squared plus L squared over 2. L squared over 4. Sorry about that. L squared over 4 equals L squared. Now, this right here is 1/4 of L squared. So let me say this. I've got a squared is equal to L squared minus 1/4 of L squared. See, dividing by 4, multiplying by 1/4 is the same. So I subtracted that from both sides. Now look at this. We've got a squared is equal to, look, 1 minus 1/4, that's 3/4. 3/4 L squared. Okay? Now if I take the square root, I'll get what the altitude is. So the altitude is the square root of 3 over 4 L squared, which is, notice the square root of 3 is just square root of 3. Square root of 4 is 2. And the square root of L squared is L, since we know for sure L is just a positive number. Otherwise, the square root of L squared would be the absolute value of L, but we know L is a length. So look, here's what we've got. Let me draw a triangle down here. Let me just isolate what we found. Okay. And we've got our right angle. Here's our right angle. And this up here is 30 degrees. And this is 60 degrees. And here's the hypotenuse. Notice that the angle opposite the side opposite the 60 degrees is the hypotenuse times the square root of 3 over 2. Okay? That's the side opposite the side opposite the 60 degree angle. Now, remember that the side opposite the 60 degrees is just L over 2. Okay? The side opposite the 30 degrees. So look, here's the thing. The side opposite the 60 degrees is 1/2 the hypotenuse times the square root of 3. Or in other words, the square root of 3 over 2L. The side opposite the 30 degrees is 1/2 the hypotenuse. So remember, to keep these straight, remember 1/2 the hypotenuse is smaller than 1/2 times the square root of 3 times the hypotenuse. So the side opposite the 30-degree angles is half the hypotenuse. The side opposite the 60-degree angle is half the hypotenuse times the square root of 3. Yeah. So, for example, let's suppose that we've got a 30, 60, 90. Okay, and here's 60 degrees, here's 30 degrees. And let's suppose the hypotenuse is 12. Okay, the side opposite the 30 degrees is going to be 6. The side opposite the 12 is going to be 6 square roots of 3. See? That's the relationship that we have here. So this is something that you want to really lock into your mind. Okay? Because like I say, you'll see reference made to this over and over again. So that's for a 30, 60, 90 triangle. Now for a 45, 45, 90, let's suppose that we've got the hypotenuse down here, and I'll call the hypotenuse C. And I will call the sides here X, because notice that these 45-degree angles, they're congruent, so the sides opposite are congruent. So let's see what we've got here. Let's use Pythagorean Theorem. We've got x squared, this side, plus this side, squared equals the hypotenuse squared. See? So that gives you 2x squared equals the hypotenuse squared. Now if I divide by 2, I get 1/2 c squared. And then x is equal to c over the square root of 2. Okay? In other words, that side, not the hypotenuse, is the hypotenuse times 1 over the square root of 2. Now we could rationalize the denominator. You don't have to. But if you took a fancy to do that, this would come out to be the square root of 2 over 2c. Yeah. Okay, so that's the relationship, that those sides are the hypotenuse divided by the square root of 2. So let's just look at an example here. Let's suppose that we have a 45, 45, 90. Let's pretend that's what this is. And let's suppose, so here is this is 45 degrees, this is 45 degrees, and let's suppose the hypotenuse is 12. And this up here is x, and this up here is x. Well, x is going to equal 12 divided by the square root of 2. Yeah, that's what that equals. Now, we could try it out. We could say, well, let's see if that works. We've got 12 over the square root of 2 squared plus 12 over the square root of 2 squared, and that needs to equal 12. Well, let's see if it does. This is going to be 144 divided by 2 plus 144 divided by 2, and let's see what that equals. That equals 144, right? Half of 144 plus another half of 144 equals 144. And look, remember, this is supposed to equal c squared. So in other words, what we have here is c squared equals 144. That means c is equal to 12. So, yeah. So these are the two relationships here, that each side, each non-hypotenuse side of a 45, 45, 90 triangle has this relationship. It's the hypotenuse divided by the square root of 2.